Again, this does not influence how it works. It is the same node. It is just visual. For the positive prompt, I will add close-up portrait of a pet. For the negative prompt, I will add cat. Not all models use negative prompts. Some older models like this one still use it, but you will see later that some newer models are smarter and do not need a negative prompt, and they work better when the negative prompt is disabled. Can you guess how these are connected? We have clip on both input and output, so we can only connect clip to clip. If we try to drag from the model, you can see it does not work, and the same if we try from the VAE. So let us connect the clip output from the model to both of the text encoders. Now we have the instructions for how the image should look, but we still need to define the size. Let us search again using the word empty and add the empty latent image node. There is also a newer one that we will use later for newer models, but for this workflow, we will use this simple one. I like to change the color of this node to purple, but you can leave it as it is if you want. Now we have width and height. Because we work with computers, most models work better with values that are multiples of 64 or 8. That is why we see values like 512 instead of 500. I know that this model was trained with square images at 512 by 512 pixels, so I use these values to get better results. Some newer models are trained with larger images and can generate bigger images, but that comes at a cost. Just like printing a big photo costs more than a small one, a bigger image takes more time to generate, and sometimes your PC cannot handle it. More about that later. Now let us add the most important part, where the magic happens, the K sampler. As you can see, this node has 4 inputs, where it takes all the instructions and 1 output. First, we connect the model, since it has the same color and name. Then we connect the conditions. The instructions are yellow. Even if the names are different, we connect the positive output to positive and the negative output to negative. That is how it knows which one is positive and which one is negative, even though they come from the same type of node. The last input is the empty latent image, which defines the size of the image we want. Now we have everything needed to generate the image, but it is still in latent format. We need pixels to actually see it. So let us drag a link from the output, and you can see that it suggests VAE decode. We select it, and now the image is decoded, like a darkroom where the photo is developed. Here we also have a VAE input. In this case, the VAE model is included inside the main model, which is why we can connect it directly. In some cases, the VAE comes as a separate file, and then we use a load VAE node. You will see that later. Now, the last step is to save the image, so we add the Save Image node. Let us run the workflow and see if it works, or if we forgot something. If everything turns green, it worked without errors. There are cases where the image does not look right even if there are no errors. That usually means some settings are not ideal. People who create AI models usually provide recommended settings, especially for the K sampler. Just like in photography, macro and landscape use different camera settings, the same idea applies here. If we look at the previous workflow, we can see recommended settings for this model. Steps 35, CFG7, this sampler, and this scheduler. So let us change steps to 35, CFG to 7. For sampler, we use DPM++2M, and for scheduler, we use Keras. Now let us run it again. For this seed, we get some small deformations, but for next seed, it looks fine. We will see later how to improve the results even more. Let me show you what happens when we try to generate an image that is much bigger than what the model was trained to handle. For this example, I will double the image size. On the first try, I did not even get a pet. Sometimes you might get something that looks okay, but most of the time you will see problems. You can get strange deformations, things that do not make sense, or visible mutations. If I increase the size even more, these problems become even more obvious. It also takes more processing power and more time to generate the image. The reason this happens is because this model was trained mainly on 512 by 512 pixel images. When we ask it to generate a much larger image, it struggles to understand the full space. You can think of it like the model trying to generate the image in parts. One part might look okay, but then it tries to continue the image next to it, almost like stitching pieces together, and that is where things break. That is why you sometimes see double heads, repeated objects, or strange structures in large images. Bigger images are not always better if the model was not trained for that size. But if a model is trained to handle larger images, you can get more details and better results. Let us say I add ugly to the negative prompt, so we push the result toward more beautiful images. For the positive prompt, let us be more specific. We want a dog, and we want it to be beautiful. Now when we run it, we get a more beautiful dog. Because this model is really old, like I told you, it is good for practice. But today we have much bigger and more accurate models. They produce better results with fewer deformations, but they are larger and need more VRAM to run properly. Our desktop computers are very similar to ComfyUI because they are both built around the idea of connecting specialized components together, where each one does a specific job. The CPU acts like the central processor, just like the sampler or the model does the main work in ComfyUI. The monitor is like preview and output nodes that show results. The keyboard and mouse are inputs, just like prompts and parameters. Printers and speakers are output devices, like save image or audio nodes. Routers handle communication, similar to data links between nodes. The reason we design systems this way is because breaking complex tasks into smaller, connected parts makes them easier to understand, easier to control, easier to upgrade, and more flexible. That is exactly why ComfyUI uses nodes instead of hiding everything behind a single button. Now that we know how to create a workflow, we also need to learn how to save it. If you look at the top, you can see it says unsaved workflow. That means none of these settings or nodes are stored yet. If you want to reuse the same workflow later, without recreating everything from scratch, you need to save it. If I click on this arrow next to the workflow name, you can see there are several save options. Personally, I prefer using the main menu. So I go to File, and here we have Save, Save As, and Export. When you click Save and the workflow has never been saved before, ComfyUI will ask you to give it a name and choose where to save it. If the workflow was already saved and you just made changes, clicking Save will overwrite the existing file with the same name. Save As lets you save the same workflow under a different name. This is the option I use the most, especially when I want to create variations of a workflow. Export is very useful because it is not limited to the ComfyUI workflow folder. It allows you to save the workflow anywhere on your computer, even outside the ComfyUI folder. The API option is mainly used when working with online or cloud-based workflows, so we will not use it here. So let us click Export. Now it asks for a name. Choose a name that makes sense to you. Click Confirm, then choose where to save it. For example, I can save it on my desktop. You can see that the file is saved with the .json extension. This JSON file contains all the nodes, connections, and settings of your workflow. This file is your workflow, and you can open it anytime, share it with others, or modify it later. JSON files are simple text files. You can open them with any text editor, like Notepad. JSON stands for JavaScript Object Notation, and it is just a structured way of writing text so both humans and computers can read it. In ComfyUI, the JSON file stores things like node types, connections, parameters, and settings, all written as text. That is why workflow files are small in size and easy to share. They do not include images or models, only instructions. If we go to Workflows, you can see I have that folder with workflows saved there. You can do that too. Go to the menu, go to File, choose Save As, give it a name, and confirm. Now if we go to Workflows, we can see the workflow is saved there. Right now it is not organized into any folder, it is just in the main list, but you can add a folder name in front of the workflow name when you save it. For example, folder name, then a /, then the workflow name. Let us see where it is saved. Go to your ComfyUI folder, then inside the ComfyUI folder, go to User, then Default, then Workflows. Here you can see your saved workflow and also the folder I created for this course that comes with the Easy Installer. You can create your own folder manually. For example, I can create a folder called My Workflows, then drag that workflow into it. Now, if we go back to ComfyUI, nothing changes immediately because ComfyUI usually reads this when it starts, but we can refresh using this refresh button. Now our folder appears there, and we can see the workflow inside it. I suggest organizing your workflows like this because over time you will have a lot of workflows and it becomes hard to keep track of everything. By the way, you can also use this search bar to search for a workflow by name. We also have a bookmark icon. If we click it, the workflow is added to the bookmarks at the top, so the ones you use the most stay there. If you click the bookmark again, it is removed from the favorites list. Let us collapse this and I will show you one more thing. If we go to the desktop and open the shortcut for the output folder, or if we go directly to the output folder, you can see all the images generated so far with ComfyUI. The last one is this dog. You probably did not think about this yet, but if you open an image generated with ComfyUI in Notepad, you can actually see some code at the beginning. Just like with workflows, this happens because ComfyUI attaches the workflow to the image when it saves it. After that, there is the image data, which we cannot really read. This means that every image has the full workflow embedded in it, including all the settings and prompts. Let me drag this image onto the ComfyUI canvas so you can see what happens. Now you can see that it loads as a workflow with the file name. If we generate again, we get exactly the same image, because it uses the same seed and settings. Let us go back to the output folder and drag a different image, for example this robot. Now it loads that workflow, and if we run it, we get the exact same robot. This is very useful. Another thing you might notice is that all images start with the word ComfyUI, followed by a number. This happens because in the Save Image node, the prefix is set to that value. We can change it. For example, I can set it to Pixa, and now when I run the workflow, the image file name will start with that word, followed by a number, as you can see here. If you hover over the prefix field, you can get more information about how to format it. You can include things like the date and other values in the file name. Now let us change it again. I will add a folder name, for example my images, then a /, then the image prefix. When we run the workflow now, the images will be saved inside that folder. Let us go to the output folder. You can see we now have a folder called My Images, and inside it we have the images that start with the prefix we set, followed by a number. Now I will go back to the Workflows folder that we created earlier and delete it. Back in ComfyUI, if we refresh the Workflows list, you can see that the folder is gone. We are left only with the Getting Started folder we used for this episode. When you create your own folders and organize your workflows, I suggest naming them in a way that makes sense. You can name them by base model, like SDXL workflows or Flux workflows, or by function, like text-to-image workflows, in-painting workflows, or video workflows. Choose whatever makes the most sense to you, but organizing your workflows early will save you a lot of time later. In this chapter, I want to show you how ComfyUI is organized on your disk. This is important because sooner or later you will need to know where to place models, images, workflows, and custom nodes. Do not worry if this looks overwhelming at first. You do not need to understand everything right now. I will focus only on the folders you actually need as a user. This is the main ComfyUI Easy Install folder. Think of this as the main workspace that contains everything ComfyUI needs to run. The most important things here are the ComfyUI folder, the Python embedded folder, the add-ons folder, and the batch files used to start or update ComfyUI. In normal usage, you will mostly work inside the ComfyUI folder. If you have a different version of ComfyUI, you will not have the add-ons folder, and some of the bat files will be named differently, but pretty much everything else should be similar. When we open the ComfyUI folder, we see many files and folders. Most of these are internal files used by ComfyUI itself. As a beginner, you do not need to touch most of these. The important folders for us are models, input, output, custom nodes, and the user folder. The models folder is where all AI models live. This includes checkpoints, LoRa files, VAEs, control nets, upscalers, and more. Inside the Models folder, everything is organized by type. For example, checkpoints or diffusion models for main image generation models, LoRa's for LoRa files, VAE for VAE files, ControlNet for ControlNet models. When a workflow tells you to download a model, it will also tell you exactly which subfolder to place it in. If a model is not placed in the correct folder, ComfyUI will not see it. The input folder is where you place images that you want to load into ComfyUI. For example, images used for image-to-image, ControlNet, masks, or reference images. Any image you place here will be visible inside ComfyUI when using a load image node. The output folder is where ComfyUI saves generated images by default. Every time you use a Save Image node, the result will appear here. This makes it very easy to find all your generated images in one place. The Custom Nodes folder is where all custom nodes are installed. These are extra features added by the community. Each folder here represents a custom node package. For example, we already use the RG3 node, and we will use more later. When you install nodes using the manager, they usually end up here automatically. If a custom node is missing or broken, this is usually the first folder you should check. Inside the user folder, we have user-specific data. The most important part for us is the workflows folder. This is where ComfyUI stores workflows that you save from inside the interface. These workflow files are saved as JSON files. The add-ons folder is specific to the Easy Install version. It contains extra tools, optimizations, and helper scripts. You usually do not need to touch this folder unless a tutorial specifically mentions it. You do not need to memorize this right now, but this structure might change as new tools are created by Ivo. For example, this bat file lets you link a folder with models from another ComfyUI installation. This one installs the Nunchaku node, and this one installs Sage Attention. There are also different TorchPack versions for more advanced users who need a specific version for certain custom nodes. You will also find extra tools, like one for Windows 10 that enables long paths so ComfyUI can download models even if the path is very long. There is also an update folder with bat files, but as you will see later, for the easy install version, I recommend using different update bat files. The Python embedded folder includes a self-contained Python installation. This helps avoid conflicts with other software and makes ComfyUI easier to run and update. As you use ComfyUI more, this folder structure will start to make sense naturally. In the next chapters, I will always tell you exactly where things need to go. Let us talk a little bit about updates and custom nodes. What you are seeing here is the ComfyUI Easy Install folder. This setup already includes everything needed to update ComfyUI safely. The most important rule is this: always close ComfyUI before updating. Never update while it is running in the browser. Start ComfyUI bat. This only launches ComfyUI. It does not update anything. Update ComfyUI bat. This updates the core ComfyUI code. Use this when you want the latest features or fixes. Update ComfyUI and nodes bat. This updates ComfyUI and all installed custom nodes. Update easy install.bat. This updates the easy install system itself. When should you update? Update when something is broken. Update when a node requires a newer version. Update when you want new features. Do not update right before an important project. Updates can sometimes break workflows. If something breaks after an update, you can usually fix it by updating again or removing the last custom node you installed. One important reminder: ComfyUI moves fast. Stability comes from not updating every single day. If everything works, it is okay to stay on your current version. At some point, you will mess up ComfyUI. Maybe a node breaks, or some dependencies get messed up, or an update has bugs. But remember, you can always do a fresh install when that happens. Just create a new folder and reinstall using the Easy Installer. Let us double-click on Update Easy Install. This updates only the Easy Installer and adds extra tools and add-ons. As we move forward in this series, more models will appear, new nodes will be added, and Ivo likes to create scripts that make these installations easier. When you see that the installation is complete, you can read more about the new release using this link or press any key to exit. You may not see any changes immediately, but if we go to the add-ons folder, you can see that we now have more bat files than we had in the first chapter. Now let us go back to the main folder and try to update ComfyUI to see if everything still works or if we break some nodes. Nodes sometimes break after an update because ComfyUI itself changes how things work internally. Many custom nodes are made by independent developers, not by the ComfyUI team. These custom nodes often rely on specific ComfyUI behavior, internal APIs, or extra Python libraries and dependencies. When ComfyUI updates, those assumptions can change, and the node stops working until its creator updates it to match the new version. So ComfyUI started after the update, but let us open the command window to see if everything worked correctly. Usually, after startup, you can see import times for custom nodes. As you saw before, all custom nodes are inside the custom nodes folder. But look what happened here. After the update, one of the custom nodes installed, like Tcache, failed to import. That means if you have a workflow that uses that node, it will not work. If you do not use that node, you can ignore it and try updating ComfyUI again in a few days to see if it gets fixed. I will close ComfyUI now and try something else. Sometimes there are newer versions of the custom nodes, and if the author fixed the issue, updating the nodes can fix the problem. So this bat file updates only ComfyUI, and this one updates both ComfyUI and the custom nodes. This process can take a while because it updates all the nodes, so I will speed it up. ComfyUI started, so let us check the command window to see if the issue was fixed. The node was still not fixed. This means that at the time I recorded this video, the update from that day broke that node. When you watch this video, it might already be fixed and work for you. Either because ComfyUI fixed a bug, the node creator patched the node, or a new developer created a replacement node. There is one more thing I want to try. We can go back to an older version of ComfyUI that did work, a version that had the right conditions for that node. The downside is that if ComfyUI released new features or nodes for newer models, those might not work on the older version, so it is always a compromise. You have to choose between keeping a specific custom node working or using the latest ComfyUI updates. Ivo hid this option so beginners do not accidentally mess up their ComfyUI. Let us go to the Add-ons folder, then to Tools, and here we have the version switcher. When we run this bat file, ComfyUI is downgraded to a previous version. In my case, it went from version 0.7 back to version 0.6. If you run this script again, it upgrades ComfyUI back to the latest master branch. Let us press any key to close this. Now that we are on an older version, it is time to check if that node works. Let us start ComfyUI, wait for the interface to load, then open the command window and check the custom nodes. Now it is fixed and there are no errors with the nodes. In a few days, I will try updating again to see if it gets fixed in the newer version. But this is basically how you update and downgrade ComfyUI using the Easy Installer. Other ComfyUI versions might require you to run commands manually, but I keep pushing Ivo to create bat scripts for these tasks. I want to spend my time generating, not typing lines of code. You will see that we have the manager here. In other versions, you might find it somewhere else in the menu. Let us open the manager and see what we have. Here we also have update and update ComfyUI. These are similar to the bat files, but the bat files have something extra. They take into account some dependencies needed for certain custom nodes to work, which ComfyUI itself does not handle when updating. For example, for the Nunchaku node to work, it needs specific dependencies, like a certain version of a library. The bat file updates ComfyUI, but then adjusts or downgrades those dependencies to the versions required by the custom nodes we use. Ivo tries to maintain these bat files and keep them updated so they stay compatible with the versions needed to run the workflows shown in these video tutorials. Because I am using the Easy Installer, I did not touch these update buttons inside the manager. I only used the bat files. If you have a different version of ComfyUI, you will need to use these update options, or use a bat file from the update folder instead. In the manager, you can also find the latest ComfyUI news, such as what was fixed, what is new, and recent changes. At the bottom, you can see the ComfyUI version and the Manager version. Most of the time, the Manager is used for managing custom nodes. If we go to the Custom Nodes Manager, we can see all the available custom nodes created by different developers. There are a lot of them. I personally try to keep the number of installed nodes to a minimum and install only what is essential or what I use most often. Some people install hundreds of nodes, but the more nodes you install, the harder it becomes to keep everything compatible.